Hi guys, Bert Kammerer with SAB Heli Division. I want to talk to you a little bit about the Goblin speed and give you some tips and some pointers on how to achieve a decent run, I guess, relatively fast speed on your Goblin speed helicopter. I also have some tips to give you about how to put it together and things to look for, but it's already been done. The same tips that I did for the Goblin competition series apply to the Goblin speed, so I recommend you watch that video. Look at your screen for the video URL. Check it out because there's some really important tips and pointers on how to build and how to maintain your Goblin speed helicopter. Again, Goblin speed and Goblin competition share a lot of the same parts, so the same tips apply. But as far as the Goblin speed, we have it right here. It's a really cool machine. It's optimized for high speed, but at the same time it has the versatility to perform as a good 3D machine as well. Speed is a discipline that really hasn't taken off much in the United States, but is really, really big in Europe, especially in Germany. Those guys go absolutely crazy to have a machine that goes really, really fast. And a lot of people think, well, flying a speed machine is boring. All you do is go right to left, left to right. It actually takes a lot of time, a lot of work, and a lot of effort to make one of these things go that fast. The faster you go, the harder it is to develop even more speed. So a lot of things need to be taken into account to have a machine that actually can go really, really fast. So I'm just going to give you a few pointers. I'm not an expert at speed flight, but I know a few things that will allow you to fly your Goblin speed at very, very high speeds. First thing, you got to make sure you have the right blades. This machine right here ships with 720mm main blades. And the blades are different from the traditional 3D blades that we have seen from SAB and from other manufacturers. They have a slightly different tip. They're optimized for high speed. What that means is you can fly really, really, really fast, and this machine will track. Thanks to its blades, it'll track better than if you're running just your traditional good old-fashioned 3D blades. And stability is extremely important, because when you go that fast, a little bit of elevator input is going to cause the machine to go crazy and try to like do a wall on its own or something. So main blades are important. Tail blades are also very important. On this machine, it ships with very small tail blades. I believe they're 95 millimeters long, and you want to make sure that you don't have super big tail blades. You don't want any drag. Drag is not your friend. So I'm going to take the canopy off, and we're going to cover a couple other things here. So as we look at the internals on this machine, another trick for high speed is high head speed. You want to run really, really high head speed. And by saying really high, I'm talking about 2,500 to 2,600. I would never recommend that you guys exceed 2,600, as we've done a lot of testing and we can conclude it's safe to say that beyond that speed, we can't really promise you that the helicopter is going to stay together at that kind of speed. But 2,500, 2,600 is safe to run. You need at least that kind of speed, rotor speed, to develop the forward speed. You want to run a 14S setup instead of a 12S setup, simply because 14S uses more voltage and less current, so things are going to run a little bit cooler. Nonetheless, things are going to heat up, because contrary to popular belief, when you're going that fast, you're maintaining a lot of collective throughout the flight, so you're using a lot of constant current. When you do 3D, you just push peaks of current and it comes back down. But when you fly high speed, you're just pushing 200 amps or something like that for like a minute at a time. So make sure that your wires are actually heavy gauge wires. These are 6 gauge. You don't need something that crazy elaborate. You can get away with 8 gauge, but use minimum 8 gauge. These are also 6mm bullet connectors. You need some good strong connectors and a good solder joint, because you don't want that to separate during flight, and it will if you don't take care of making sure that your solder joint is done correctly. So short wires from the ESC to the motor, I mean the shortest that you can have, and that's one of the reasons why this machine has a speed controller mounted high close to the motor. Short wires from the ESC to the battery, heavy duty wires, heavy duty connectors, and so forth. So again, these are some of the pointers. Aside from that, make sure your flabberless system is set up correctly. You want practically no tail gain. The less the tail gain, the more power that you have reserved for your main rotor. So run practically no tail gain. If you can run rate mode, even better. And then other than that, just go out there and have fun. We're going to go ahead and take it for a spin. All right, here's the Goblin speed. This one is set up for speed, so we're going to give it a shot. I'm only going to do a couple of fast speed runs, maybe right to left and left to right. This one is 100% stock setup on this helicopter. This one's got a 480 kV motor with a 22 tooth pulley 14S at 90% throttle. As you can hear, it is ripping. I got a few cameras just in case to see if we can get footage of this, because it's not easy to do. But we'll try it. Yesterday I attacked this at 151 miles an hour. Well, left to right, here we go. And like I said yesterday, this was 151 miles per hour. I don't know that I'm getting that today, but. So one trick here is, after you do these speed runs, is have a lower throttle curve and bring the throttle down like I just did. Probably can't see it well in the video, but make sure you're throttled down a little bit here and there, because you really don't want at all to create too much heat in the system and burn something up. Again, these things use a lot of current. This helicopter could have higher speed if I went with a bigger pulley, which I probably would end up doing in the future. But for now, I think this is decent speed at 150 miles per hour. All right, so that's what we have for speed flying. Now this is my Goblin speed number 2. This one is set up for 3D. So the only thing I did is I changed, of course, the gear ratio on this machine. I put a 23 tooth pulley on the motor with the 480 kV Contronic motor, 12S only instead of 14S. No need for 14S, just for 3D flight. And I have normal SAB blades, 3D blades, and normal SAB tail blades. Obviously my setup has changed. My gain on the tail is much higher, and it's just my typical 3D setup. I also installed the 3D landing gear, which is kind of cool looking. You can run this landing gear also if you want to do speed with it. The reason why the angle in the landing gear is like that is because we've done a lot of testing. If we've determined that the angle minimizes the drag, so it gives you the least amount of drag for the type of landing gear we're running here. So that's why it kind of has that funky angle. But landing gear is just a matter of preference. I prefer the wider landing gear on this machine, simply because I'm going to be flying it more often. I'm doing 3D with it. I also put the quick release canopy mounts right here, which you don't have to, but it makes it easier to insert and remove the canopy. But other than that, this thing flies just like the other Goblin. It's just a great 3D performer. So we're going to take this one for a quick spin too. All right, I have my other speed helicopter right here set up for 3D. Just going to do a little bit of 3D with it. Here we go. Just gonna do a very quick sort of very quick 3D session here. And the head speed on this helicopter is 2200. This is just a typical like head speed I use for 3D. But as you can see, this thing will just do 3D no problem. Just like any other Goblin. Pure flips. That's it. Just basically give you an idea that the machine can not only fly fast, but it can do some 3D as well.